Introduction to Neural Networks with C#, Class 11, Part 1. Welcome to Class Session 11 of Introduction to Neural Networks. My name is Jeff Heaton. I will present this class session to you. In Class 11, we are going to learn about how to apply the predictive neural networks that we learned about in Class Session 10 to the financial markets. In particular, we will look at a program that attempts to predict the direction of the SP 500. Of course, this program can't exactly predict the SP 500, or it would be worth its weight in gold, but it does show how we can actually predict with a neural network and apply it to the financial markets. In reality, you would want to use this program to augment another investment strategy, or more likely put a lot more data into it and locate relevant data to allow the neural network to predict such a trend. This neural network is going to take as input previous results from the SP 500 as well as the prime interest rate. It will use these two pieces of information to attempt to predict the direction of the SP 500. We will look at an actual program that does this in a later part of this class session, and you can see the results for it. While it does not accurately predict the SP 500 in most cases, it can predict some actual trends in the SP 500. We will begin by looking at how the program is structured and how we're going to create the input for this type of a neural network. It's going to use a feed-forward backpropagation trained neural network. However, we're not just going to use backpropagation. We're going to also use simulated annealing in conjunction with backpropagation so that we get a sort of hybrid training algorithm. If backpropagation no longer trains effectively, which likely means that it's reached a local minima, we're going to kick in the simulated annealing to help get over the particular local minimum that we've encountered. This will allow the training to be more effective, and it also shows you how to implement a hybrid training algorithm. We will begin looking at the program and seeing how it is actually run. This is the most complicated neural network that we presented so far in this course, and it can train for a considerable length of time. You can train for hours or even days to try to get the neural network to an acceptable error rate. Because of this, you'll want to be able to save your neural network, so the program can be ran in a variety of ways that allow you to save the neural network, train it some more, or evaluate the results. This is all presented in several parts, and you can execute each of these parts independently of the others. The book companion download also contains a SP 500 neural network that I trained for several days to try to get the error rate to a reasonably acceptable level. We'll also look at this in a later part of this class session. We begin by looking at the structure of the example program. This program will attempt to predict the SP 500. Here you see the SP 500. It is an index of 500 American stock companies that are listed on the stock exchange. You can see that the SP 500 has generally increased over time, although here lately it has decreased considerably. We will write a program that will look for patterns in this data and attempt to predict future trends in the SP 500. We will also use the prime interest rate in the United States. The prime interest rate is a standard bank rate set by the Federal Reserve. This is an interest rate that determines the availability of money, which has a direct impact on the stock market. We will use this as data to be fed to the neural network, as well as the historic prices of the SP 500 in order to predict trends. It's relatively easy to obtain both the SP 500 as well as the prime interest rate data. To obtain the SP 500, you can use Yahoo Finance. If you feed the URL below to it, it will return the SP 500 as a CSV, or comma-separated value file. The CSV file returned from Yahoo Finance provides you with a great deal of data. we're going to only use some of this data to actually attempt to predict the S&P 500. This file is provided by the companion download for the book and will be used by the CSV reader that is also provided by the book source code. We will read this data in and use it to generate training sets along with the prime interest data. The prime interest data can be also obtained from the internet. It can be obtained from a variety of places, such as the Federal Reserve Bank. The data for the prime interest rate does not fluctuate as much as the stock prices do. The prime interest rate does not generally change from day to day. It is set at board meetings by the Federal Reserve Bank. Here you see the URL where you can obtain the prime interest rate data. The prime interest rate data looks considerably more simple than the S&P 500 data. You'll notice that there are really just a few values per year, if even one value per year. This is because the data is only recorded when the prime rate actually changes. This is something that the program will have to account for because it needs to stitch up the prime interest rate values to the corresponding days that are provided by the S&P 500. Both of these data sets are at different levels of granularity, but they need to be commonized in order for the program to be able to feed them as inputs, because we will feed the prime interest rate data that it currently is into the neural network along with the S&P 500 financial information. This together will form the input to the neural network. How the neural network is structured is very important to its operation. The neural network has an input layer and an output layer like any other neural network that we looked at in this book. We're going to look at how those two structures were created. There's also hidden layers. The hidden layers are completely arbitrary. They are defined in a configuration file that we're going to look at in the next class part. And this configuration file allows you to have either one or two hidden layers and to specify how many neurons should be in each of these two hidden layers. Generally, you'll have just one hidden layer. However, two hidden layers are allowed just in case you want to experiment with seeing if two layers will produce a better result. Really, this comes down to trial and error or using some sort of an automated pruning approach to find out exactly how many hidden layers are useful to have with this type of a neural network and how many neurons to have in these hidden layers. The output is a single neuron that specifies the percentage that the S&P 500 is predicted to move as a result of the input. The input is also configurable by the configuration file. You specify how many periods you want to come into the input layer. So if you specify 5 periods, then 5 periods are going to be used to predict the 6th period. You will use a total of 10 values if you are specifying 5 periods, because we're also using the prime interest rate as well as the trailing historical data from the S&P 500. All this data feeds in together to train the single output that predicts the percentage move of the S&P 500. Now that you've seen how the example program will collect data from the S&P 500, we're going to look at how to actually run the program and the various modes that the program can operate in. We will look at this in Part 2. We hope you will continue with Part 2. Thank you. This course is based on our Introduction to Neural Network Programming books for Java and also Introduction to Neural Networks for C#. Available in both paperback and ebook format.